Well, welcome everyone to another section of Chapter 6. This is section 6.2, where we're going to continue looking at triangles, but in this particular case, the function is right-angled triangles. We're going to deal with them. So let's look at the objectives. We're going to do some trig ratios, looking at special triangles that allow us to find exact values of sines, cosines, 6 trig ratios, and applications of them. Well, let's begin by talking about how do you name a right-angled triangle? Well, in this particular situation, you've got to imagine that there's one angle. And in this case, we'll call it theta, is down here. From this angle's perspective, three sides are called the opposite, which is this one, because it's opposite the angle, the adjacent, because it's next to it, and the third, the longest one, hypotenuse. If you notice that the hypotenuse is longest, it's also opposite the right angle. So for any given triangle, if you give me an angle to look at from, then you should be able to describe the names of the three sides that make it up. Now, the reason we need to know this naming is because there are in fact 6 trig ratios. They are called sine, cosine, tangent, cosecant, secant, and cotangent. And it's very often a little mnemonic called SOHCAHTOA. If you look up here, SOHCAHTOA. That allows us to memorize at least 3 of them. The sine, for instance, is opposite divided by hypotenuse. The cosine is adjacent divided by the hypotenuse. The tangent is opposite divided by the adjacent. And that gives us these. So for instance, if I know the lengths of the 3 sides and I know this angle, I should be able to tell you what the sine, cosine and tangent ratios for those particular angle. Now, if you want to get the cosecant, the secant or the cotangent, these 3 ratios essentially are married to the sine. The cosecant is the reciprocal of it. Essentially, the numerator and denominator switch places. The secant is the reciprocal of a cosine, so the ratio you get here is hypotenuse over adjacent, and the cotangent is the reciprocal of the tangent. Opposite over adjacent now becomes adjacent over opposite. So here's some examples. Suppose you have a triangle here. This angle's called theta, and the sides are 3, 4, and 5. Pretty standard triangle, called the Pythagorean triple, by the way. From this angle's perspective, if I wanted to know what the ratio for the sine of that angle theta is, I would realise it's opposite over hypotenuse. Now from this angle's perspective, the opposite is 3, the hypotenuse is 5, so the answer is 3/5. Now if you look at this triangle, which is essentially the same guy as this, it's just 10 times bigger. The sine of this angle is still opposite 30 divided by adjacent 50, and when you simplify it down you get 3/5. So can you imagine an extra little line here? That's where this triangle would fit, right in here. But if you did a bigger one or a bigger one or a bigger one, it wouldn't really matter. The cool thing about for any given right angle triangle, if that angle's the same as this angle, then the ratio for the sine always ends up being the same value. And that's a very important property. As long as the right angle triangles are similar in shape, all 6 trig ratios will be the same. Now let's look at this one, a little bit bent and off angle, but from this angle's perspective, opposite is 2, adjacent is √5, and hypotenuse is 3. And here are the 6 trig ratios. Opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then if you take reciprocals, you've got the other 3, the secant and the cosecant and the cotangent. Well, let's look at some special right angle triangles that can be used to find the exact value of some trig ratios. Well, imagine you had a square where it was 1 by 1. You split it with a diagonal. You will make a right angle triangle, and it's not hard to show that this length is root 2. Just use Pythagoras. But from this picture, you can find the sine, cosine, tangent, as well as the secant, cosecant, and cotangent. Well, how would you do that? Well, can you imagine just doing opposite over adjacent, and you would be done. So that particular triangle allows us to get all the 45s. Now suppose we look at this triangle. It's a little bit different. It's a 30-60 triangle. This side is root 3, this side is 1, and this side is 2, which you can definitely check if you drew one. And you put those together. This triangle here, for instance, will allow us to get, well, let's take an example. Suppose I want to know what the sine of 60 is, right? This angle is 60. From this angle's perspective, then, isn't the sine opposite over hypotenuse? So it would be root 3 over 2. Suppose I wanted to know the tangent of this. Well, it would be opposite root 3 over 1, which is root 3. Well, suppose I wanted 30 degrees. Now, from 30 degrees, the names of the sides are now changed because it's in relationship to the angle that you name the side. So from this angle's perspective, this guy is the opposite and it's 1, and this guy here is root 3. The hypotenuse never really does change. It's still the hypotenuse no matter which of these two angles you use to name the other sides. So suppose I wanted to find the cosine of 30. Cosine adjacent over hypotenuse, root 3 over 2. And here's a table that, with the little triangles to the side, that actually contains all these standard angles and their sines and cosines and their 6 trig ratios. Every single one of these you can in fact calculate. There are some rather awkward ones. Take 90 degrees. Well, if you imagine what a 90-degree angle would look like, it would just be a vertical straight line, so there would only be one dimension. So this would be 1, this would be 0, but 1 divided by 0 wouldn't be a good idea, so these two are indicating that it's undefined. Right, suppose you want to find a calculator. Well, on your calculator you can either have in degree mode or you can have it in radian mode. That's important, because the sine of 30 degrees and the sine of 30 radians are not the same thing. So make sure when you're doing these on your calculator that you're in the correct mode. The usual convention is if the angle is a degree, they put that tiny little degree symbol. So it would say 1 degree or 15, a little circle degrees. If there is no degrees symbol here, then you treat it as a radian angle. Now you can get the sine, cosine and tangent on your calculator because they're simply just buttons that you press. To get a cosecant or a secant or a cotangent, it's worth using the reciprocal property. In other words, the cosecant is 1 over the sine of t. It's the reciprocal of it. There's the 1 over cosine, which gives you a secant, and a 1 over tan, which gives you a cotangent. Now, for instance, the sine of 1 radian is this number, but the sine of 1 degree is this number. These you can get by just looking at your calculator. Suppose you were asked to calculate these. Here are some examples. You can certainly check them out in your own time. Comes out pretty standard. Well, let's look at an application. Well, before we get there, we need to be aware of some terminology that is used in some of these questions. Now, essentially, when you're doing these, we have an angle that is being used to name the sides. In this case, A would be called the opposite, B would be called the adjacent, and in this case the hypotenuse is 12. So one of the things you have to be aware of is that your given angle decides what the names of these three sides are going to be: opposite, adjacent, over hypotenuse. Now suppose the question here, we wanted to find A. Let's say I wanted to find A. Then what I would say is to myself, okay then, I know the hypotenuse, and A is the opposite. Which one of the 6 trig ratios uses opposite and hypotenuse? And the answer is the sine. So the sine of 30 degrees would be opposite over hypotenuse, A over 12. Oops. And to get from this line to this line, you can multiply both sides by 12. Some people think you're cross multiplying. And eventually you get 12 times the sine of 30. We know that the sine of 30 is a half because remember the table at the top. But of course you could just do it in your calculator. In many cases you will probably have to because the numbers won't be standard angles. From that same picture, if you wanted to look at that picture, oopsie daisy, you go back. So if you wanted to look at that picture and find, say, B, let's start from this perspective again, adjacent over hypotenuse, right? From this angle's perspective, this side here, the one that has a little B on it, is adjacent, and this one here is hypotenuse. So the one that uses these two is the cosine. So the cosine of 30 degrees would be this guy, multiplied by 12. In this case, you can get an exact value, but in many cases it would be a decimal that you need to round off. Well, let's look at some names, some terminology, some more. Imagine you have this person outside the building and there is a guy washing the windows and there's a poor guy down here. From this person's perspective, if you imagine them staring straight forward, that's the horizon or the horizontal, and then they look upwards to see the guy here, then this distance, this angle here is called the angle of elevation. So you might get a question that says the angle of elevation is 20 degrees or 44 degrees or whatever. On the other hand, this guy, this person is a woman, I believe, looking downwards from her horizontal. This is called the angle of depression. The red line is called the line of sight. So you can imagine the line of sight to here is that red line, and it's part of an angle of elevation because from the horizontal she has to look upwards to see this. And this is called an angle of depression. From the horizontal she needs to look downwards to see that. Well, let's pretend that we had a big tree and that we wanted to find its height. And we've walked 532 feet. And right at the bottom, you measured the angle to the top. And it's 25.7 degrees. So can you imagine a little right angle triangle is now being formed? This side is called H, the one that we want. This is the 532, and this is the angle. Well, from this angle's perspective, won't this be called the opposite, and this will be called the adjacent? So the trig ratio that uses those two is the tangent. So the tangent to 25.7 degrees is opposite, H, over adjacent, 532. A little multiplication or cross multiplying, and you get roughly 256 feet. And that is us. I hope that was useful.